Hello, I'm just adding this comment to the start of the video because I've made an edit to the original video, and that's because I messed up question 30 the first time I went through this paper. I just go through all of the questions, record my answers, and then post the video up. This error that I made in question 30 was a big enough error that I thought I'd redo the question and then just insert it into the original video. So you'll see a little bit of an edit going on around about question 30. I thought about doing a separate video and just saying, well, here's a correction, but then people don't always watch corrections if they're in a separate video. So I thought it'd be safer to remove the original one and then re-upload with the edited question 30. So it's the only time I've actually done this in one of these videos of making a change, but I think the error was big enough to make it worthwhile. So if you've already seen this video before, the original version, that's why I've re-uploaded it. If not, then it will be, be fine. If you're watching it for the first time, I've just put that correction in if you notice any cuts coming around question 30. Right, off we go with the rest of the recording. Hello, this is the second part of the ENGAA from 2023. I'm not going to do part A of maths and physics because all of the questions in that section were in the natural sciences paper for that year, and I've already recorded those videos, so there's no point just going through the same questions again. So if you're interested in part A, go off and look at the NSAA videos from 2023. So I'll do the 20 questions in the advanced section and see how these ones go. So question 21, we've got x squared minus x minus 6 is a factor of this. What's the value of a plus b? Right, so we've got an a here, a b here. These are real constants. So this thing is x minus 3, x plus 2. So if I put x is 3 and x is minus 2 into this thing, I'm going to get two things that equal 0. So when x is 3, I'm going to get 27 plus 9a plus 6 plus b is equal to 0. When x is minus 2, I'll get minus 8 plus 4a minus 4 plus b is equal to 0. Subtract the bottom one from the top one. 35 plus 5a plus 10 is 0. So a is, what's that, minus 45 over 5, minus 9. So b is then, let's go into the bottom one here. B is going to be 8 plus 4, and then minus 4 lots of a, so plus a 36. So that's 48. And I want a plus b, so that would be 39, which is not, oh, it is there, it's h at the bottom. Okay, not a bad start. 22. Two pipes contain air at the same temperature and pressure. A stationary sound wave is formed in the first pipe, which is closed at one end, open at the other end. Okay, so we've got one of those sort of pipes. The lowest frequency of stationary sound wave that can be formed in this pipe is 4,000 hertz. Right, so we've got a quarter of a wavelength is fitting in the pipe, and we've got 4,000 hertz. Second pipe has got the same length, but it's open at both ends. Right, okay, so we've now got half a wavelength in there. What is the lowest frequency of stationary sound that can be formed in the second pipe? Right, so the fact we're fitting half a wavelength in there, so we've dropped the wavelength by a half, so the frequency must have doubled. So we must have 8,000 hertz. 23. Arithmetic progression has first term a, common difference d. Sum of the first 9 terms plus the sum of the first 10 terms is equal to the sum of the first 11 terms. Wow. Which of the following is the correct expression for a in terms of d? Right, so first 9 terms. So we've got a plus d, a plus 2d, etc. down to a plus 8d. So that means we've got 9 a's, and then we've got the 8th triangular number for d, so that's 8 times 9 over 2 times d. And then I need to do the same for 10, so that would be 10a plus 9 times 10 over 2 times d. And that is going to be equal to first 11 terms, so 11a plus 10 times 11 over 2 times d. So get the a's, let's get a's on the left then. So I've got 19 minus 11, so that's 8a. And then the d's I'll have on the right, so that's 55. And then I'll have to take off 36, and I'll have to take off 45. And that's d's. So I've got 10 minus 26 So A is going to be minus 26 over 8D. So minus 13 over 4. So A. Right, 24. Cannonball of mass 2.6 kilograms fired horizontally from a cannon at the top of a cliff at a speed of 90 meters per second. Okay, so draw a velocity arrow, not a force arrow there. 2.6 kilograms. Okay, height of the cliff above the horizontal ground is 45 meters. What is the magnitude of the impulse that acts on the ball between leaving the cannon and reaching the ground? Right, so the 90 meters per second is neither here nor there, because we only care about what's happening in the vertical direction, force due to gravity. And so, well, I mean, we can see this in the units. Everything's Newton seconds. We know what the newtons are. Newtons going downwards, our newtons is going to be 2.6 times 10. So that's 26. And we need to multiply that by the time. How long does it take to drop 45 meters? So 45 meters is our average velocity times time. Our average velocity is gt over 2, as in the average of the, half the accumulation of the acceleration, seeing as we started at 0. So we've got that 45 is gt squared over 2, which you probably notice being s equals ut plus a half at squared, but I'm no fan of SUVAT. I don't think it's good physics. So we've got this. G is 10. So we've got t squared is 9, which means t is 3, which means that our impulse is 3 times 26, which is, what, 78. So D. 25. The first three terms of a convergent geometric progression are these. What's the sum to infinity? Right, so we've got geometric progression. The ratio of consecutive terms is the same. So 2p over p minus 3 is p minus 3 over p minus 7. So 2p squared minus 14p is p squared minus 6p plus 9. P squared minus 8p minus 9 is 0. So what's that? P minus 9p plus 1 is equal to 0. So we've got p is 9 or minus 1. What sequences do we get for this? If it was 9, we get 18, 6, 2. That looks like our sequence. The other one I assume doesn't work. We've got minus 2, minus 4, minus 8. So we don't want that one. We want this one. So we've got A is 18. Sum to infinity. A 18 over 1 minus R. So 2/3. So that's what, 27. G. Question 26. Child on a sledge travelling straight down a snow-covered slope, constant speed of 15 meters per second, 60 kilograms. Okay. Angle of slope is 30 degrees. What is the rate at which thermal energy is being produced due to friction forces? Right, so we've got friction going that way. We've got our mg going down there. So our friction is going to be, let's say constant, constant speed. So our friction is going to be mg sine theta. So that is 600 over 2. So we've got 300. And we're going at 15 meters per second. So we just need to multiply those and get C. Well, that was a quick one. Right, diagram shows a circle with center O. Right, is this find X? Yes, you have to find X. Right, there's a lot of lines here. We've got two diameters, but we haven't got anything coming off the same chord, which is a bit annoying. So 55, the 40, the X, they're all coming off of different chords. That's rubbish. So we're going to have to draw in some new lines. What new lines are going to be sensible here? Actually, this one looks great going down here, doesn't it? Because not only is that giving two angles coming off the same chord that are 40 degrees, i.e. that is 40 degrees, it's also giving a right angle here. So if that's 40 degrees, that must be 15 degrees, so that must be 75 degrees. Okay, a little bit of detective work on that one. 75 degrees, E. Well, that's quite a nice one. I do like geometry questions. Diagram shows a battery with no internal resistance, 4 identical resistors, P, Q, R, and S. Just a Q dissipates 4 watts of power. Okay. What is the total power supplied by the battery? Right, so we must have another 4 watts from R because they're identical. What are we saying then? We've got, well, we got these two in parallel, so they got half the resistance. So they're going to have half the voltage across them. So P and S have got double the voltage. We've got V squared over R is our power. So we're going to have 4 times the power on P and S because we've got double the voltage. So we're going to have 16 watts there and 16 watts there. We want the total wattage. So that's going to be 40. 16, 16, 4 and 4. So E. Okay. 29, the function that can be written in that form. Oh, we need to work out P, Q and R and then the value of that. Okay. Right, that's an ugly looking thing, isn't it? So let's take that root 2 out of, what did I say? I really need to take it out of 4, do I? Anyway, let's say root 2 x squared. So if I divide this by root 2, that's going to be 3 root 2 x. And then I think I can leave the 4. I don't need to mess around with a 4. So that's going to be root 2 x minus 3 root 2 over 2 squared. Still got the plus 4, but then I need to take off what is going to be 9 over 2 times root 2. So 9 root 2 over 2. Okay, that seems to be in that format. So I now want P is root 2. Then I've got to do R minus Q. So that's 4 minus 9 root 2 over 2. That's my R. And then Q minus Q. So that's going to be a plus 3 root 2 over 2. So I want to do all of that. So that's going to be 4 root 2. And then I've got a minus 6. Is it just minus 6? Yeah, because then I'm going to multiply by the root 2, which is going to cancel with the 2 at the bottom. So 4 root 2 minus 6, assuming I've done that. Okay, so F, at least it's still there. Heart in mouth until you actually see if the answer's there. So on to question 30, which is the cause of me re-recording part of this video, which is kind of annoying because this is the sort of question I'd expect to do quite easily, but I made a right hash of it when I went through the first time here because I like a mechanics question, but you know, still managed to mess these things up when you're going at speed, even when it's a topic of choice. Right, so we've got 2 identical uniform thin planks, each of mass 40 kilograms, propped against one another in equilibrium on a rough surface. Right, so each plank is at an angle of 30 degrees to the vertical. What's the magnitude of friction force at point P? Right, so we've got let's look at the left-hand plank on here then. So we'll have the weight going downwards. So it's 40 kilograms, so we've got 400 newtons there. We've got a reaction at P. Call that R, and then we've got the friction going that way. We're going to have a similar thing for the right hand plank, but I'm not going to consider that one. And then up the top we've got a reaction coming off of the plank that it's leaning against, so we can call that some other, let's call that R2 and this one R1. So I'll do moments about this point at the top where they're touching each other, because that means we don't have to deal with R2. But also we have to think about what R1 is. So resolving in the vertical direction for this left-hand plank, we're going to see that R1 is 400 newtons. That's our only upwards force. The 400 newtons is the downward force. So we've got 400 newtons there. Then we can go about doing our moments about the point at the top. So we've got a going, what's that going to be, clockwise, isn't it? We're going to have, let's get our angles in the right place. So that's 30 degrees. And that means also that that is 30 degrees. So we've got 30 degrees there. So we've got going clockwise, we've got an R, so a 400, that's our R1 sine 30 degrees. And then that is going to, multiplied by the length of the rod, if we say that has got length L, all the way the length of the plank. So we've got that, and that has to be equal to, we're going to have a 400 sine 30 degrees times L over 2 from the weight, and we're going to have an F cos 30 degrees multiplied by the whole length of the rod. So I can take that off of both sides, which is just going to make that 400 sine 30 times L over 2. So I've got 100 L is equal to F root 3 over 2 L. Get rid of those. F is equal to 200 divided by root 3, which is answer B. So there we go. So yeah, not that bad a question really. I mean, I just made a complete hash of it the first time I went through, but that's as I say, often the way when you're going through these questions really quickly. Question 31, which of the following is equal to this? Right, okay, so I've got, well, let's take the constant outside of the integral. I'll have an x cubed over 3 minus root 5, and a minus, okay. Right, so that's just going to double up because we got a cubed. So, and then they're going to cancel with the one on the outside for one of them. So I'm going to have a 3 minus root 5 squared times 2/3. Yeah, that seems pretty good. So I'm going to have 14, that's my 9 plus my 5. And then I'm going to have minus 6 root 5. And that's going to be multiplied by 2 over 3. Right, does that look like any of this? Yeah, it looks like E all the way. 28 minus 12, yep, so E. That's good. 3 blocks, P, Q and R, are in contact on a horizontal surface as shown. The mass of P is 4 kilograms, right, that's all in the question, all in the picture, so we don't need any of that. Horizontal force is 20 newtons, yeah, we don't need any of that. Friction force between P and the surface is 2 newtons. Okay, so I've got 2 there. Between Q and R is 1, so we've got 1 there and 1 there. Okay, so 1 newton. That's right, fair enough. What's the magnitude of the force that R exerts on Q? God, this is quite involved, isn't it? So for, well, I might draw these out individually. All right, so for P, we've got 20 going forwards. We've got whatever's coming back from, we've got Q pushing back on it, and we've got 2 pushing back on it. So for all of this then, we've got the 20 minus 2 minus Q is equal to 4 times A. So that's for P. So if we do similar things then for Q and R, so for Q going forwards, we've got whatever this Q is, and we're going to have R pushing backwards, and we're going to have 1 from the friction, and that's going to be 2 times A. For R, we're going to have R pushing forwards and 1 friction coming back, which is 2 times A. Right, so we've got all of this. So I could add, what's the best way to do all of this? I could do, well, I mean, the top one, I've got that Q is equal to 4A minus 18. Oh no, that's minus Q. Q is equal to 18 minus 4A. And then I could put that into the bottom one then. I've got 2 equations for R then, haven't I? So I'd have 18, let's go down here, 18, there might be a better way of doing this. It feels like I'm getting quite long-winded here. I'm now putting Q into this second equation. 18 minus 4A minus R minus 1 is 2A. And then I've got R minus 1 is equal to 2A as well. All right, so these things are the same as each other. So, yeah, this really doesn't look as though it's going to be a good setup on all of this. Well, I suppose maybe it would be. I don't know. Anyway, so I've got that. How am I going to do this? Well, I can work out what R. Well, let's add these together. Let's just add them together. I've got an 18 minus 4A minus 2 is equal to 4A. So I've got that A is equal to 2, which means that R is equal to 5. Right, which is B. Right, there's got to be a quicker way of doing that one, I would have thought. But I don't know, maybe not. We are in the last 10 questions or the last 8 or 9 questions of this, so maybe it is quite a long-winded one. I mean, who knows? Right, question 33. A function f is defined by that where a and b are constants. It's given that the first derivative of f, you put 1 in, you get 2. Second derivative, you put minus 1 in, you get minus 2. What's a plus b? Right, this seems fairly standard work on this one then. So f dash of x is going to be minus a over x squared, and then minus 2b over x cubed. So when I put a, what are we putting in? We're putting a 1 in. So I'm going to have minus a minus 2b is equal to 2. Okay, and then f double dash. So that is then going to be 2a over x cubed. And then I'm going to have plus 6b over x to the 4. And we're putting minus 1 in. So minus 1 is going to give us minus 2a and then plus 6b. And that's equal to minus 2. Okay, let's double this first one then. Minus 2a minus 4b is equal to 4. And then I can subtract one from the other. So let's subtract this one from the bottom one. So that's going to give me 10b is minus 6. So b is minus 3/5, which means that a is going to be what? A is, let's go back into this one. I've got a is equal to 2 plus 2b plus 6 over, no, I've done that the wrong way around. A is equal to minus 2b minus 2 is a. Right, so minus 2b is 6 over 5, and then I take 2 off of that. Okay, so that's going to give me 4 over, minus 4 over 5. Right, okay, a bit fiddly, more fiddly than I thought this was going to be, this one. What am I trying to do? A plus b. So that is minus 7 over 5, which is c. Okay. Right, yeah, that was just fiddly with the fractions rather than anything else. An object is released from height h, from rest at height h above the ground, falls freely in a uniform gravitational field. At time t after being released, it has fallen a distance s in as at height h above the ground. Okay, right. Travelling at speed v. So when it's here, it's travelling at speed v. Graph shows two quantities plotted. Which of the rows shows a possible pair of quantities? All right, so how many of these work? Right, so we're saying h against t. So h, the height against time. Well, that isn't good. That's definitely not going to be 1, because we know that we've got h is proportional to t squared. So it's definitely not going to be 1. Like kinetic energy and h. Yeah, I mean, that's going to work from energy transfer, isn't it? Because we've got our mgh going to our half mv squared. So if we're doing kinetic energy and h, so kinetic energy is proportional to h. So that's going to be fine. And our GPE and S. I mean, S and H are essentially the same thing. Whether you're doing, because you could just rewrite S and H, you could say that S is equal to H minus H. So it doesn't, they're the same thing. It doesn't matter which one we're using. Right, GPE, well, that'd be fine as well, because that is proportional to H or S, whichever way we're looking at it. So it's going to be 2 and 3, which is G. Okay, that's good. Find the real value of x that satisfies this thing. Right, so we've got log base 3, so we've got an annoying 2. So let's turn that into a log base 3 as well. So that's going to be log base 3 of 9. So we'll have x squared plus 3x plus 2 is going to be 9x squared plus 18x. So we just have to figure this out and see which one still gives us a log answer. So that's 8x squared plus 15x minus 2 is equal to 0. So that is going to split, isn't it? 8x squared plus 16x minus x minus 2 is 0. 8x, then we'll have an x plus 2, and then minus an x plus 2 is 0. 8x minus 1, x plus 2. So we've got the x is minus 2, or it is an 8th. I'm guessing minus 2 is going to be the one that causes a problem. What is that going to cause a problem? Yeah, because we're going to get a 0 there. So it's got to be the 8th, which is A. Right, not many to go here. A 20-volt battery of negligible internal resistance connected in series with a 20-ohm resistor and a cylindrical conductor. whatever that is. The current in the circuit is 0.2 amps. Cylindrical conductor is now removed, melted and reformed into a new cylinder. It's after the cylinder is cooled to its original temperature, its length is 4 times greater, so L times 4. Okay, so that means that our cross-sectional area will be times 1/4 because we've got the same volume. What is the resistance of the new cylinder? Right, so we need the resistance here. So we know the total resistance is 100 ohms because we've got our V equals IR, so that must be 80 ohms. And resistance is going to be that times that over that. So our resistance has gone up by 16. So we want 80 times 16. So what's that? 1280 E. Okie dokie. Right, what is the constant term in the simplified binomial expansion of this? Right, so what is the middle one on all of this? So we want to do our 8 choose 4, so it's going to be 8 factorial over 4 factorial 4 factorial. So that's going to be 8 times 7 times 6 times 5 over 4 times 3 times 2. So I can get rid of that and that and that, and then that and that, and make that a 2, so that's 70. And then I'm going to have 4 2s and 4 4s, so that's going to be, well, I'm going to divide that by 2 to the 4. So 70 over 16. So B, 35 over 8. Okay, that's quite a quick one. Sound wave can travel from a source at P to a detector at R directly or by reflecting at Q. Okay. The angle between PR and PQ is 30 degrees. Yeah, distance from P to R is D. Okay, so that's all the picture. There's a phase difference of pi between the incident and reflected wave at Q. Okay, so that's important information. Waves that reach R via Q are in phase with waves that reach R directly from P. Okay, which expression gives the greatest wavelength of sound waves for which this is true? So we need that the path difference then is going to be half a wavelength, isn't it? So we've got D, if this is X, say, then we've got D, we've got 2X, so 2X minus D has got to be half a wavelength because we're getting half a wavelength in this phase difference between the incident and reflected waves. So that's what we're after. We've also got the X cos 30, so X root 3 over 2 is D over 2. What am I trying to get here? I'm trying to get the wavelength in terms of D. Right, so I want to get rid of X. So put this into that. So 2X is going to be 2D over root 3 minus D is wavelength over 2. So the wavelength is going to be 2D times 2 over root 3 minus 1. Oh, it's A. Right, it's the one that's actually on the screen. So that is helpful. Question 39. Given that x squared plus y squared equals 1, what is the greatest possible value of that? Right, okay, I mean, this has been, interestingly, I've been discussing this in tutorials recently of someone who uses, or a few people use this. It's not something I was that familiar with, really. I think it's Cauchy-Schwarz. A lot of people use this. I'm not going to use it. It's a quick way of getting this answer. You can look it up and see how it works if you want to have a quick fix for getting these greatest values. I'm going to go through what I was originally doing when answering these sort of questions. This sort of question comes up on numerous papers. I haven't seen this specific example before, but I've seen it on other papers. And I'm just going to go through what I do, and then you can add it to your repertoire of things that you might use as solutions or methods for solving these sort of equations. I do these via implicit differentiation. So I will differentiate both of these. We want to maximize 2x plus 3y. So let's differentiate it. So I'm going to get 2 plus 3 dy dx. So we want this to be equal to 0 in order to get a maximum. So we're saying dy dx is going to have to be minus 2/3. I can differentiate the other one, the equation of the circle, get a 2x plus 2y dy dx is equal to 0. and then I can, you know, plug in to, well, I know what dy dx is in this particular case. So I'm going to get that 2x, well, I can get rid of the 2's actually. I can say that x is going to be 2/3 of y. So I've now got, you know, I've got a relationship between x and y, which is going to make all of this quite easy to figure out. So I can put this back into here and then say, right, well, I've got a 4/9y squared plus y squared is equal to 1. So that means that y squared is going to be 9/13. And then, so I've got y is 3/√13, which means that x is going to be 2/√13. And now I have to get the greatest value of this. So that is going to be 4/√13 plus 9/√13. 13/√13 is √13, which is g. So it is significantly more long-winded than using this Cauchy-Schwarz thing. But if you haven't come across this, I don't know if it's on the syllabus or not. I'm fairly sure it probably wouldn't be for the ENGAA, but that doesn't mean to say you can't use it. You know, a lot of people use it because it is a lot quicker than doing it this way. But this implicit differentiation approach, I don't see people using it all that often, and you can use it in a wide variety of situations. I think the Cauchy-Schwarz one, from recollection, I think this applies to when you're looking at circles. So, but this approach, you can have any equations here and just differentiate them and plug them in the same way, treating them as simultaneous equations. So pros and cons, you know, certainly not knocking this as an approach, and if it's something that you use, then great, but you don't need to. Or you can, you know, solve it in the more standard algebraic way, which I think is how people go about these questions. But I just thought I'd throw in something different with implicit differentiation. Right, on to the last question then. So two springs have spring constants 200 newtons per meter and 600 newtons per meter. Okay, joined in series end to end stretch. So combined extension is that. What's the total strain? Right, okay, so this one stretches 3 times more than that one. So we must have a 0.6 meters for that one and 0.2 meters for that one. So I can now do a half, so a k, so it's that, times the x squared, so that's 0.6 squared, plus a half of the k, which is that, times a 0.2 squared. So that's 100 times, well, that's 3/5, so 9/25, plus 300, well, times 1/25. So what have I got here? 36, and then 12, so 48. So a quick finish on the physics ones. The physics ones seem relatively quick in this section. The maths ones seemed relatively long. I would say this seemed a bit harder than previous years, these 20 questions. And that last one was fine. That one was quite long-winded, unless you know the trick. That one wasn't too bad again for the physics. But yeah, okay, that one was quick. That one was fine. That one was, yeah, I don't know, maybe some of them, that one was quite long-winded. They just overall felt as though they were more difficult than previous years. Not by a lot, there was still plenty there. That one, this one here was quite unpleasant, wasn't it? 32. 33 was fiddly with all of the numbers, so it was getting bogged down in the middle. I think that was the thing. So it wasn't too bad at the end, but the middle was quite involved. So yeah, they did seem quite long. This one, 29, again, it was quite long. So I don't think they necessarily had the most difficult ones at the end of the set of questions. They had some nice ones at the start. 27 would have been quite easy to miss what to do there. So yeah, it was an interesting set of questions, but I reckon overall that was a bit harder than 21, 22 as years go. So there you go. That's the ENGAA 2023.